Hi class, my name's Tiffany and I'm a graduate student at George Mason University in the Health Informatics program. This presentation was prepared as part of the HAP 671 course on entity relationship diagrams. What are entity relationship diagrams? They provide a structural diagram for databases. Just as the name indicates, it is a list of entities and their relationship to each other. Let's take a closer look by defining each of these components. Entity is defined as a tangible object or concept. Examples include person, object, concept, or event. Entity is essentially the same as a table. In entity relationship models, entities are often represented by a rounded rectangle. Each entity has a name, definition, and type. This brings us to our next point. Attribute is a set of characteristics used to describe an entity. It also has a name, definition, a type, and constraints. Patient ID, first name, last name, telephone number, and address are all attributes as they are specific characteristics to the entity, in this case, patient. For instance, after indicating the name of the attribute, the specific type is shown in parentheses, such as varchar to indicate string or integer. Putting it all together. If a patient entity or table were created, an attribute or field would include a specific characteristic of that patient, for instance, patient's first name. The data inputted into that field, such as the name John, would be the value. The purpose of entity relationship diagrams, or ERDs, is to increase efficiency by removing repeated information and eliminating missing data. It also provides links between various different entities. When comparing entity relationship diagrams to a database, to understand connection between the terminology. Entity refers to a table. Attribute refers to a field or column within that table. Links between entities refers to primary key and foreign key. Looking at this example of a student table, let us identify some of these terms. The columns listed here, such as student ID, student name, login, age, and GPA, refer to attributes. The data inputted into the rows refer to values, records, or relational instances. Cardinality refers to the number of rows, in this case it would be 3, and degree refers to the number of columns, in this case it would be 5. The primary key in this example of a student table is student ID. The primary key. It is unique to each row of the table. There cannot be 2 or more records that share the same value for a primary key attribute. In this example of a product entity, the third line shows an incorrect record, as it is the same as the value that's already being used. What is a foreign key? This is what is used to form relationships between other tables or entities. A foreign key in one table corresponds to a primary key in another table. In this example, employee ID is the primary key in the employee table, and a foreign key in the security table as it links the two tables together. There are 3 types of relationships in an SQL Server database. The first one is a one-to-one relationship. This means that one record of the first table will be linked to one record of another table. In this example, there are 2 entities, employee, and employee details. Each employee in the employee table will have a corresponding row in the employee details table storing details such as passport number and expiration. The link between the two tables is the employee ID, which is both the primary key and the foreign key. These type of relations are rare and are often used to avoid missing data. The next type is a one-to-many relationship, which is the most common type of relationship. In this case, a single record from one table can be linked to more than one row in another table. For instance, in this example, there are two tables, employee and address. Employee ID is the primary key of the employee table, and address ID is the primary key of the address table. Employee ID is the foreign key of the address table as it allows for the two tables to be linked. Each employee will have one record in the employee table, but each employee can have many addresses such as home address, work address, previous and current addresses. The last type is a many-to-many relationship. This happens when multiple records in a table are linked with multiple records in another table. Relational databases will not allow for a direct many-to-many relationship between two tables. As a fix, there is a join table or linking table, which will combine the two tables through matching fields by use of primary keys from both tables. In the join table, these match fields are referred to as foreign keys. In this example, we are trying to link the student table and the class table. The join table in this example is the enrollments table, which uses student ID and class ID as foreign keys to link both tables together. Now we will be discussing the first two questions of the LM9 assignment. In the first question, we are asked to create a many-to-many relationship between patient table and address table using the following attributes. In the second question, we are asked to enter 5 rows of data into each table showing that 2 individuals can live at the same address and 1 individual can have 2 addresses, one current and the other previous. To start question 1, we can start by creating a patient table and including the 3 attributes of patient ID, first name, and last name. We will indicate that patient ID is the primary key and include the type of attribute such as integer for patient ID and varchar for first name and last name. Next, values are inserted into these 3 attributes to create 5 rows of data. The second part of this question is to create an address table using attributes of address ID, apartment, street, number, and zip code, and indicate address ID as the primary key. We also include integer and varchar accordingly. Values will need to be entered accordingly in a similar manner. We now have 2 tables, a patient table and an address table. The second question asks us to link the 2 tables with a join table. In this case, we use residential status table with the attributes patient ID and address ID, which are both primary keys, as well as current address and previous address. In the first part of the question, we are assigning the same address ID for 2 different patients. If you'll notice, patient 1 and 2 both have an address ID of 1, which show the same current address. We are also showing that one patient can have two different addresses. If you reference patient number 3, you'll notice that there are both a current address and previous address listed. This brings me to the end of my presentation. I've attached some references. Thank you for listening to my presentation.